Hi, everyone, and welcome to Backer Breaks It Down. In this episode, we are going to look at proofs involving complementary and supplementary angles. Because if you want proof, I'll give you proof. Okay. So in the diagram below, angle 1 is supplementary to angle A. Okay, and angle 2 is also supplementary to angle A. Notice that the measure of angle A is 70 degrees. So, how large is angle 1? What about angle 2? How do angles 1 and 2 compare? So, since angle 1 is supplementary to angle A, and we know that supplementary means that they add to be 180 degrees, we know that angle 1 is 110 degrees. And since angle 2 is also supplementary to angle A, we know angle 2 is 110 degrees. So angle 1 is congruent to angle 2. So what is illustrated here is something known as the congruent supplements theorem. The congruent supplements theorem, there are actually two versions of this. The simple one, the one that we just saw with our own two eyes, is the one that says if angles are supplementary to the same angle, then they are congruent. Okay, and so if you look at what we're given, it says given angle 3 is supplementary to angle 4. Given angle 5 is supplementary to angle 4. So we have sup. Okay. So the most basic way that I can describe a congruent supplements theorem and congruent complements theorem is if you're given sup and sup, you can prove congruence. Okay, so we're given the angles are supplementary to the same angle, angle 4, right? And that makes them congruent to each other. Another version of this theorem says if angles are supplementary to congruent angles, then they are congruent. So once again, realize you have sup and sup, okay? But notice this time, all four of those angles are different. You got angle F is supplementary to angle G, angle H is supplementary to angle J, and then they tell us that angle G is congruent to angle J. Okay, so here we have their sup to congruent angles, which makes the other two angles congruent. And if you want measurements to help you fully understand this, let's say that angle G is 50 degrees. And since it's supplementary to angle F, that would be 130. We know that G and J are congruent. So that means H, since it's supplementary to J, would have to be 130. And then the proof is that angle F and angle H are congruent to each other. The congruent complements theorem works the same way. Okay, so here notice we're given comp and comp. Here they're comp to the same angle, and that's why 4 and 5 are congruent. So if comp and comp, then congruent. Okay. So let's see these theorems in action. In fact, let's use one of these theorems to prove that vertical angles are congruent. Now, like, we know this. We've used this theorem a lot. We used it like in algebra problems, but we also used it in our congruent triangle proofs. So it's been used a lot, but we've never proven it. Okay. Now, when we prove a theorem, you are not allowed to use the theorem in your proof. Trust me, I tried that when I was a geometry student and I was wrong. Okay, so we are not allowed to use vertical angles are congruent. No. Okay, so how else can we prove that angle 3 and angle 4 are congruent? Okay, well, all we have been given is the diagram. And since we're not allowed to use vertical angles, what else can we possibly use? That's right, we could use linear pairs. So I can bring angle 3 into this proof by saying that it forms a linear pair with angle EBC. Okay, so I can say that angle 3 and angle EBC form a linear pair. Why can't I say that? You're right. That is one of the few things I'm allowed to assume from the diagram. Oh, I think I just heard someone think the same thing about angle 4. Okay. So I can say like the same thing about angle 4, that it also forms a linear pair with angle EBC. So why is that worth mentioning? This whole business about these two angles forming a linear pair. That's right, because if they form a linear pair, that means that they're supplementary. Okay, so I'm going to say that next. Okay, so I'm going to say that angle 3 is supplementary to angle EBC. I'm going to say the same thing about angle 4, that it is supplementary to angle EBC. Why are they supplementary? That's right, the linear pair postulate. The linear pair postulate says if two angles form a linear pair, then they are supplementary. Way to go. Okay, so let me bring us back to what we're trying to prove here. We're trying to prove that angle 3 is congruent to angle 4. Now, both of these angles are part of our proof. Like here's angle 3, here's angle 4. What else do you notice? Oh yeah, we said they were 3 was sup to angle EBC. 4 was sup to angle EBC. So they're supplementary to the same angle. So what does that mean? Exactly. That means they're congruent. So we can say that angle 3 is congruent to angle 4 by our congruent supplements theorem, which says if two angles are supplementary to the same angle, then they are congruent. So here is the proof as to why two vertical angles are congruent. And now in the future, we can simply use that and it'll be much quicker. Okay. All right, so let's take a look at one more application of these theorems. So let's write down our given information and then we'll get started. Angle O is complementary to angle 2. And angle J is complementary to angle 1. Now, our goal is to prove that angle O is congruent to angle J. Is there anything jumping out at you? Comp. Yeah, I'm seeing that too. And so we know that if we're given comp and comp, we can prove congruence, okay? Because the congruent complements theorem, let me just go back to it, says if angles are complementary to the same angle or to congruent angles, then they are congruent. So taking a look back at this proof here, are they complementary to the same angle? No, they're not, okay? Like O and J is what we're trying to prove are congruent, but they're not complementary to the same angle. In fact, they're complementary to two different angles. So the question is, these two angles, are they congruent? Yeah, they are congruent. You're right, they are vertical angles. So here we see in our diagram that angles 1 and 2 are indeed vertical angles. Now, I do not need to go through that whole big process from the previous proof. No, because I proved that theorem so I can use it once again easily in proofs. So remember, when we want to use vertical angles, we first have to say that they're vertical angles. So angle 1 and angle 2 are vertical angles. And that, once again, is something that we can assume from the diagram. And then we can immediately say that they are congruent to each other. So angle 1 is congruent to angle 2 because vertical angles are congruent. All right, so now that we know angles 1 and 2 are congruent, and we've proven that, we are ready to say that angle O is congruent to angle J by the congruent complement theorem. Because if two angles, right, so two angles are complementary to congruent angles, they are congruent. Congruent complements theorem, right? And so there you have it. Proofs involving these two very useful theorems. In fact, that congruent supplements theorem is how we were finally able to prove two vertical angles are congruent. And that is how Bakker breaks it down.